Hey, Rusty Bob's quick video for you. I picked up a drill press a little while back, and the motor was was single phase, 220, 240 power here, split phase. So one of the windings is a starter winding, and it uses a centrifugal switch to turn off the starter winding when it's started. They want like $400 for a new motor, and can't allegedly get parts for the motor. So of course you can never get parts for the motor because then you don't buy a new one, right? So I found a old water pump that the pump was actually shot, and I'll flip the camera around because comments from some of the previous videos is you don't like looking at my ugly mug. So because I'm filming these on my iPhone, my arm is only so long, so I can only get so far from my face. Anyways, I'll flip you around on here, show you what I got, show you how I'm gonna mount it to this drill press, and comment below. This is the little drill press I picked up. Got it for $100. It's probably that much weight in cast iron. So it's an older Tanner unit, and I've been led to believe that Tanner here, Australia, and in the UK is the same as Atlas. Comment below if I'm totally off on that, but some of the Tanner drill presses I've seen, not this one particularly, but some of the other ones, I actually had an Atlas and it looked exactly the same. Anyways, so this is a little unit. The motor actually mounts on the top here, so it actually keeps it really tight, so you can have it up against the wall, which I really liked. That motor was the one that I said was a split phase starter, so I can't just, usually it's just the capacitor that goes on them. Well, not in this case. It's only a little 4-speed, but what I'm doing here pretty much going to be all I need. Everything else works nice and smooth on it still. I'll tidy up a few of those other things and maybe look at upgrading the chuck at some point, but to buy a new one, you're probably right. I can probably get a whole new unit for the price of putting a new motor on this one, but it's not going to be solid cast iron like this thing. Even though it's what they call a benchtop model, it still weighs almost 80 kgs. Like, what is that, like 200 pounds, something like that? So definitely a nice little unit. Even the deck itself isn't, I mean, obviously you got the hole in the middle that's all wallered out, but it's in still pretty decent shape. So this plate up here, there's a cover plate right here, which this ring is too big for the other pump, so I'm going to make a new plate, and then that'll mount nicely on there. So this is the pump that I had sitting under the bench here. It was an old water pump, and got all growly. It was a, what is it, 1, 2, 3, 4, 5-stage pump. So it was a pretty decent little water pump. And so it's got this extra long shaft on it, which obviously once I get the new plate mounted and the pulley mounted, this has to be, the bottom of the pulley has to be 82 mils from the bottom of the plate. And then I'll just cut off whatever's left. And yeah, so this little pump, well, those are the specs there. So it's 2,900 revolutions per minute, which is a little fast. 1.5 kilowatt peak, 1.1 kilowatt running continuous, which the old pump, or the old motor on the drill press, is probably only a half horse, and that's like, well, you guys can do the maths on that. And but 6.2 amps, not too bad. And it's capacitor start, so generally when these don't start, it's because the capacitor's shot, and those are cheap. They're only like 10, 15 bucks. I'll clean it up, obviously, but it's got to mount vertical in there, and that's where you normally get into the problem, because these are usually, you can see on the end there, clockwise rotation, which if it was a standard drill press like they make now, they would mount like this. Well, then you'd be running in reverse, which obviously you don't want. Look how wobbly that shaft is. But because it's mounted vertically on the top, not on the bottom, perfect, right rotation. So I'll get that plate cut up tonight, mounted on there. It's got nice little screw holes here. It had these long bolts holding it in, so I'll just cut these down to size and then thread them up here. So I think it'll work great. So this is the plate that I made up. The old one was the hole and it was too big for this particular motor. So what I did was, this is actually the pump face on here, but on this particular motor the pump face is cast in with that piece there. So I left that pump face on there, and I think that'll come in handy later. So painted it up, some new screws. This was the cord here, I just wired it into that guy. The outlet is there, so that's at the end of the 5 stages. But what I'm going to do is I'm going to put a bung in there, so when it's spinning, that's the shaft right there, and I'll put in an RPM sensor right there, so that's handy. And I can just get a bung and then drill a hole and tap it and screw the RPM sensor in there. It's a bit fast, so I've got it wired in here to the old switch and plugged in. So when I spin it on, it runs good. You can see the shaft in there spinning. So this is the slowest pulley combination that this one has, and I calculated it out with the pulley calculator online that right now it's running, the pump runs at, it says on here 2900 RPM, which means that it's a 8-pole motor. 4-pole motor would run at half that, so whatever that would be, 1350 or 1450 RPM, which was what was on here before. So this one runs exactly twice the speed as what the original motor runs, but it also runs at 3 times the horsepower. And so on the slowest pulley combination, there's calculators online. You can put your RPM in and then the size of your pulleys, and it spits out the number instead of doing all the math myself. So it's running at 1120 RPM right now on the slowest setting. So that's fine for any small diameter stuff, but that's way too fast for larger stuff or step bits or anything like that, or hole saws or anything like that. It's going to be way too fast. So what I've got going is a speed controller coming, which says that it'll do single phase motors, and some people have said no, you can't do a single phase motor on a variable frequency drive speed controller. But it was like 20 bucks from China, so I'm gonna give it a whirl. My only thought is that I might not be able to, I'll have to start it on no speed controller, and then, because the starter capacitor might not have enough high enough frequency to start. But theoretically it's only the starter winding that should cause the problem. Otherwise it'll function the same as a speed controller on a 3-phase. That's the theory. That's what I've read online. Comment below if you think differently, if it's just gonna burn my motor out, but I'm gonna try it anyways and we'll see what happens. Little fix, it was free, which is great because a motor for this thing in New Zealand here is like 400 bucks, and that I can probably buy a whole drill press for 400 bucks. So for a couple hours of tinkering when I had nothing to do, and I got a 2-horsepower drill press, so even if the speed controller reduces the power output, I've still got way more power than I'm probably ever going to need with a tiny little drill press. And I'm sure at some point I'll upgrade to a better one, but this thing is like cast iron boat anchor. It's solid. There isn't even hardly any movement in the shaft. Everything works the way it's meant to. So what more can you ask for? So I paid $102 for that drill press. It was meant to be running when I got it. It wasn't. That's the risk you get sometimes when you buy things online or Trade Me or eBay or Craigslist or whatever have you. But for a free pump that was sitting under the bench doing nothing and the pump itself was shot, the motor was still good, we'll see what happens. Hey, like the video, subscribe to the channel. Check you next time.